Question 6. Identify 4 types of mechanical and electromagnetic waves. Well, let's do the mechanical waves first, shall we? So mechanical waves are waves that travel through a medium by means of the particles inside the medium vibrating. Each vibration of a particle will cause the particle next to it to vibrate due to contact forces. So in this case, we can look at things like sound, which is air particles vibrating back and forth and knocking the air particles next to them. And those will vibrate back and forth and therefore hit the particles next to them. And so the disturbance will propagate outwards. Another example is water waves. In this case, it's the water particles knocking each other back and forth or moving up or down and pulling each other together with surface tension. So ripples on the top of the water are carried by surface tension. So it's a form of mechanical wave. And sound waves underwater are carried through collisions between water particles. And so once again, that's a mechanical wave. Seismic waves, what cause earthquakes, these travel through the ground like a sound wave, except rather than air particles vibrating, rock particles are vibrating. Finally, transverse waves on a guitar or violin string. If we pluck or bow a guitar or violin string, the string will vibrate, and that will cause the air particles near it to vibrate, which will of course produce sound. Alright, so we've listed 4 different mechanical waves now. Let's get on to some electromagnetic waves. So these are the invisible waves that propagate and cause things to light up. We can see them with our eyes if they're shining straight in, and so we can see them reflected off other things. So right away we can say that visible light is one form of electromagnetic wave, but it turns out that there are some forms of wave that we can't see, even if they're shining into our eyes. And those are things like ultraviolet light, which comes from the sun and causes sunburn, infrared light, which we usually feel as heat, and finally something like radio waves, which travel invisibly and can be used to transmit information over long distances. Question 7. Recall 2 differences between mechanical and electromagnetic waves. This should be fairly easy, I hope. Mechanical waves have to travel through a medium because they travel through particles interacting with each other mechanically or through contact forces. Electromagnetic waves don't need this. They travel by creating alternating electric and magnetic fields, and with these they can travel through empty space. Another difference is that different sorts of mechanical waves will propagate at different speeds, depending on the medium. So for example, sound waves generally travel faster than waves caused by surface tension on the surface of a pond. But all electromagnetic waves travel at the same speed, and they travel at, in fact, faster than any other wave in the universe can travel. Question 8. Compare the motion of particles in a transverse wave to the motion of particles in a longitudinal wave. Now, can you remember the difference between these two? In a transverse wave, the particles will vibrate in a transverse direction to the wave's motion, which means perpendicular, and for a longitudinal wave, they'll vibrate in a direction that is longitudinal to the wave's motion, which means in the same direction. So in transverse waves, the medium oscillates perpendicular, and in longitudinal waves, the medium oscillates parallel to the direction of energy transfer. It turns out that there are 1 or 2 other forms of wave, such as toroidal waves. If we think about a spring that we twist up, when we let go of it, it'll twist back into its original shape and then keep going. After it's done that, it'll twist back again. And so we'll get a clockwise twisting and then a counterclockwise twisting, and that will repeat. So what we have there is a toroidal wave, which is traveling not across, but in a circular direction. Question 9. Classify the following waves as transverse or longitudinal. A ripple in a pool of oil. Now in this case, we have a mechanical wave that's causing the oil particles to move up and down and to affect other oil particles with surface tension. If an oil particle moves up and down and then affects the next one with surface tension, then when the first oil particle goes up, the second oil particle, pulled up by surface tension, will come up next to it, and that'll pull up the next oil particle, and so on. And so we get the wave propagating. If the oil particles are moving up and down, and the wave's propagating in that direction, then they're vibrating perpendicular to the wave's motion. So we have a transverse wave. How about a sound wave traveling underwater? Now if we look at ripples on the top of the water, then they'll be using surface tension. But underwater, we can have sound waves, which travel in the same way that they do as in air. That is, we get a particle vibrating back and forth and bumping into its neighbors and causing them to vibrate back and forth as well. And then they'll bump into their neighbors and and so on, and the wave will propagate through the water. So in this direction, if the wave's moving in that direction, and then the particles will have to be vibrating in the same direction as well. And that means that they'll bump into each other, right? So we have a longitudinal wave. How about a radio wave broadcast from a satellite? Now this one's a bit harder, because in this case we don't have any particles vibrating. There aren't any particles in space where satellites are, and so we have to travel without particles. In this case we don't have particles vibrating, but we do have electric fields forming in a direction that's either longitudinal or perpendicular to the wave's motion. Can you remember which? That's right, it's transverse. So in an electromagnetic wave, like a radio wave, the electric field that causes the wave to propagate is transverse to the wave's motion, that is, perpendicular. Finally, question 10. Are gravity waves mechanical waves? Explain your answer. Now, let's think for a moment about what mechanical waves are. They're waves that travel through a medium due to the fact that particles are bumping into each other or otherwise using contact forces to affect each other. Now, gravity is not a contact force. We're affected gravity from the sun, for example, and the moon is affected from gravity from the earth, and yet all of these are in space, so there can't be any particles connecting them. So that means that gravity waves, assuming they exist, can't be mechanical waves. So we can put that down right away, and then we can explain our reasoning for it. In a mechanical wave, the particles transmit wave through contact, whereas a gravitational wave requires no medium and travels through a vacuum. And so we can see that gravity cannot be a mechanical wave. Alright, that's the end of the questions, which means we're at the end of the lesson. So in this section, we've looked at some of the differences between waves. We've compared gravity waves, light waves, sound waves, and looked at a few different ways of classifying different sorts of waves.